Hi, third grade. Today we are going to be going over Investigation 11 on volume for your math instructional video. So investigations, remember, have a couple extra objectives. Might also be a little bit of a longer video because we go through everything together for an investigation. They've become my least favorite to record because I cannot see your expressions to see if this is hitting, your brains the right way, if you're having light bulbs go off, if this is making sense or not. And I'm not hearing feedback with you helping me out with the answers. I'm just waiting and then giving you the answers. But we only have one more investigation to record after this. Volume, our objectives are count cubes to find the volume of rectangular solids, find the volume of rectangular solids, and estimate the volume of real-world objects. So some of the background knowledge that we want to be accessing for this lesson, we want to be thinking about the geometric solids lessons that we had where we saw different rectangular prisms and stuff like that. We want to be thinking about a little bit about our capacity investigation where we had the different jugs of different sizes, and we were using empirical units for that lesson, but it showed how much fits inside of something. That's also volume. The capacity is what could be the maximum volume that will fit into this thing. So we're going to be thinking about that a little bit. And then if I had thought further ahead with the, when I was packing up stuff to bring home to record videos, I would have also brought with me some of the base 10 blocks. So I want to think the first time that we were doing place value really early in the year, I've also brought those things out for manipulatives a couple of other times, but we had like teeny tiny blocks that are ones. And then we showed how 10 little blocks in a row is the same as a base 10 strip. And then we showed how 10 strips in a row makes a square, and that's 100 block. And then we showed how a layer of 10 100 blocks makes that big 1,000 cube that I have. And that's kind of also what I want to be visualizing while we're going through our investigation. Now, if you were doing this electronically, the first page is not on your Google slide because this is just information introducing the problems, and the Google slide is really just a place for you to enter your answers so that I can see what you are doing. So you will not see this first page on the Google slides in the Google Classroom assignment. You will also notice that on the last slide, there's 5 slides for the investigation. If you're paying attention as we're going through the video, you're going to have almost all of those answers when it's time for your investigation. The very last slide, slide number 5, looks a little bit distorted and stretched out just because of the way that I cropped the scan of the worksheet. So you'll still be able to enter your answers. It just won't look exactly the same as the worksheet. The proportions will be different. So this is what I was talking about with accessing that background knowledge and visualizing the example with the 1,000 block and the or the 1,000 cube when we're doing with base 10 blocks. So it says volume is the amount of space a shape occupies. Volume is measured with cubic units. So 2 different ways to label this is you could say like CU cubic feet, or cubic centimeters, or cubic inches, or cubic meters, or you could just put that label with a 3 next to it, similar to when we're doing area and we say inches. It could be square inches, SQIN, or it could be IN with that exponent 2. This would be the exponent 3 added to your label to show cubes, which is meaning I'm showing you that this is volume. It's 3-dimensional, which is why there's 3 different numbers that we will need to be multiplying rather than just 2, like when we find the area. So they're giving you an example of a cubic centimeter, and then this is a cube. They're saying this is a cubic inch. It has 3 dimensions. So there's 3 different things that you're multiplying. Then on that next bullet point, it says here's a model of a rectangular solid. And we should be familiar with that from our geometric solids or a 3-dimensional polygon. This we would call a rectangular prism. But they're showing you 3 different layers, and you can see that there are cubes in each layer, similar to that 1,000 block with our base 10 manipulatives. I can see that there is a length, or it says a length of 3, a width of 2, and then a height of 2. And sometimes they'll say depth. So it depends on, which curriculum we're using. Sometimes it'll say length times width times depth, or length times width times height. Same thing. Now, one way that I can look at this, it says it's built with cubes that each have a volume of 1 cubic centimeter. So each cube is 1 centimeter. There are 2 ways to find the volume of this rectangular prism. I could look and see how many cubes are in one layer, and we did something like this similar on another worksheet. And I could say 1, 2, 3, 4, 5, 6. There's 6 cubes in one layer, and then say how many layers and multiply that. There's 2 layers, so there's 12 cubic units. These units are centimeters, so it's 12 cubic centimeters, 12 centimeters cubed. Or we can use the formula, volume equals length times width times height. Length times width, 3 times 2 is 6, times height times 2. So 6 times 2 is 12. 12 cubic centimeters, 12 centimeters cubed. So the front page is just setting up the investigation. Now we're going to go over some actual examples together. I also feel like when we do investigations and I'm using the worksheet instead of the whiteboard, it's harder to see for you guys. So I hope that this is making sense. All right, so it says try both ways to find the volume of the rectangular prism in problems 1 through 4. And they give us a reminder of what that formula is, and then they also kind of help set up how to do it the visualization way. So it says how many cubes are in each layer. So I'm going to count them up. 1, 2, 3, 4 cubes per layer. How many layers? There's 2. They already answered that for me. So I'm going to do 4 times 2 equals 8. And one thing is you should get the same answer no matter which way you're doing it. And that's a good way to check your work, is by trying it 2 different ways and seeing that you get the same answer both times. Now I'm going to look at the length. This is a true cube, so they're all the same. My length is 2 feet. Make sure you're paying attention to labels. My width is also 2, and my height is 2. And then PEMDAS, I do multiplication and left to right. So 2 times 2 is 4. 4 times 2 is 8. 8 cubic feet. I think I might have said the wrong units up here. I can't remember. All right, moving on to a different one that's not quite as easy because it's not a true cube, but we're still using cubic units to measure it. So how many cubes are in each layer? 1, 2, 3, 4, 5, 6, 7, 8. How many layers? 1, 2, 3 layers. They already filled that in for me. 8 times 3 is 24. And then they filled in some of this for me at the bottom. I don't know why they did it on this example and not the one at the top. Maybe because this was a true cube and they thought that that was easy enough. So my length is 4 centimeters. My width is 2 centimeters. My height is 3 centimeters. So 4 times 2 is 8. 8 times 3 is 24. Now, we're going to do another one. This is another true cube. So it says, how many cubes in each layer? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cubes in each layer. How many layers? 1, 2, 3. 9 times 3 is 27. 27 cubic inches. The other way that I could do that would be 27 inches cubed. It is hard to write on this clipboard while I'm holding it up and not flat. All right, now length times width times height. My length is 3 inches. Make sure you're using labels so you don't forget it. My width, 3 inches. And my height is 3 inches because this is a true cube. So all of those sides are going to be exactly the same. 3 times 3 is 9. 9 times 3 is 27 inches cubed, or I could say 27 cubic inches. All right, number 4. Again, how many cubes in each layer? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many layers? 1, 2, 3, 4. 12 times 4. 48 cubic meters. And then I'm going to use the formula, length times width times height. My length is 4 meters. My width is 3 meters. And my height is 4 meters. All right, so I'm going to multiply. 4 times 3 is 12. 12 times 4 is 48 meters cubed. All right, the next bullet point says, remember that 3 feet equals 1 yard and that 9 square feet make up 1 square yard, because 3 feet and 1 yard are interchangeable, because sometimes we see problems on worksheets or problem sets or tests where they'll give us something in feet and they'll want the answer in yards. So we've got to convert it either at the beginning or the end. They've done that too with meters, centimeters, millimeters, where they'll give you the problem using one type of unit and they'll want the answer in a different kind of unit. What is the volume of the cube in cubic feet? Now they helped us out because they showed us length times width times height in feet. They also showed us length times width times depth in yards. So they want it in feet. We don't have to do any conversion here. They kind of helped us out, but they illustrated that those are the same. So my length is 3 feet. My width is 3 feet. And my height is 3 feet. Three times 3 is 9. 9 times 3 is 27. And I'm going to do feet cubed, but I could also say cubic feet. And when I turn my page, I'm going to take a second because it is pouring outside right now, and Hazel does not like storms. So she's been clawing at my legs while I'm trying to teach. So I'm just going to put her on this chair right next to me so she can feel a little bit safer, because I love storms. She doesn't like storms. She's afraid of storms, but she loves me. So she thinks that she needs to be brave and come check on me whenever there's a storm. See, she's hanging out doing math, doing the math investigation with us. I think that's so cute. All right, on the next page. We're going to skip number 6 because it says, what's the volume of the cube on page 700? You guys don't have a textbook at home. I didn't bring a textbook home. I brought these worksheets home. So you will notice that on your, on the Google slide, there's not a spot for you to enter answers on there. This cube has a volume of 1 cubic meter. So now we're working with metric units. What is the volume in cubic centimeters? So remember, 1 meter equals 100 centimeter, because that prefix cent means 100. Like there's 100 cents in a dollar. There's 100 centurions in a unit of 100. So what is the volume of this cube in cubic centimeters? So they have the length and the width already filled in. 100 times 100. They did offset multiplication. They set that up with offset multiplication. And it says multiply in your head, because we know identity property, 1 times 1 is going to be 1. And I can just add my zeros on my end. I've got 1, 2, 3, 4 zeros to add. 4 zeros. I'm going to count 3 place values over, add my comma in. 100 times 100 is 10,000 square centimeters, because that's 2-dimensional still. Now they want us to add that in with the square centimeters here. So I'm going to put 10,000. And then they already put down my next factor. They want us to multiply it by 100. And I can do that on my head too. I can say it's going to have a 1. And it's going to have 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6, adding in my commas. So 10,000 times 100 is 1,000,000 cubic centimeters in a cube that is 1 cubic meter. Suppose that the storage area of a delivery truck is shaped like a box. It is 5 feet wide, 6 feet high, and 20 feet long on the inside. What is the volume of the storage area in cubic feet? So we're going to do this problem first, and then on the next page, we're going to see an illustration of that truck. Because we're going to have to figure out how many boxes we can fit in that truck. So what is the volume of the storage area in cubic feet? So they want the width. They said 5 feet wide. And then the height, 6 feet high. And I'm going to do that first. 5 times 6 is 30. So it's 30 square feet. That would be like 1 layer, 30 square feet. Now I'm going to add that in where it says square feet, and they already put 20 as my length. They already put that in there for me. Now I could do this, I could do double multiplication, and I could have zeros for everything on there, because they didn't set this up for offset multiplication, which I like to do with multiples of 10. Instead, I'm going to use mental math for this. I am going to multiply 2 times 3, which is 6. And I'm going to add my 2 zeros on the end. 1, 2 zeros, 1, 2 zeros. 600 cubic feet, or feet cubed. Both would be acceptable. On the next page, they're going to show us the dimensions of a box, and we're going to have to figure out, based on that 600 cubic feet for the volume, how many of these boxes are we going to be able to fit in that truck. So this is real world math, because if you end up working someday where you're going to have to be shipping stuff, you're going to need to know those if you work for a company that needs to ship things. Now, suppose the truck is to be loaded with boxes with the dimensions shown. So here we have the box. It's 2.5 feet for the length, 2 times the width, and 3 feet for the height. The first boxes are stacked along the back wall, which is 5 feet wide and 6 feet high. So here's an example. This is like the very back of the truck. It's 5 feet wide, 6 feet high. How many of these boxes can be stacked against that back wall? Complete the diagram to show your answer. So if I'm looking at 2.5 feet, and then I have 5 feet, I can fit 2.5 plus 2.5 is 5. So I can fit 2 boxes across. They're 3 feet high, and the total height is 6 feet. So I can do 3 plus 3 is 6. I can fit them 2 high, and 2 across. So how many boxes can I fit in one layer just stacked all the way against the back of that truck? 1, 2, 3, 4. Each layer of boxes is going to have 4. So I can fit 4 boxes. And I'm going to remember that because on the next page, I'm going to have to figure out then how many total boxes I can fit. I'm going to have to figure out the next direction. This is the page that's going to be looking interesting on your Google Slides, because when I cropped this, I didn't put in these extra activities because you don't need this. We don't have our books at home with us during this learning at home. So it says, if the same size boxes continue to be stacked in the truck in the same manner, then how many boxes will fit in the truck? Explain your answer. Each stack of 4 boxes, and I should have looked back at this to see what the next thing was. So 2.5 wide, 3 high. The other dimension that I'm missing is 2 feet. So they're 2 feet wide. So I can have one stack that's going to come 2 feet in towards the end of the bed of the truck. Visualize a semi filled with boxes. So each stack of 4 boxes, each layer of 4, takes up 2 feet of the 20 feet. The 20-foot length of the truck. This means that how many stacks of 4 boxes, which is how many total boxes, fit in that semi. So I'm going to see how many groups of 2 can I fit into 20. So it'd be 20 divided by 2. I could do it with a fraction, with a division bar as a fraction. 20 divided by 2. 20 divided by 2. Or 20 divided by 2. Twenty divided by 2. 2 divided by 2 is going to be 1. Add my 0 on the end. 10 stacks of 4 boxes. So if there's 10 stacks of 4, how many total boxes are going to fit into my semi-bed? Identity property, 1 times 4 is 4. Add my 0. 40 boxes can be shipped in one shipment on that semi. So if you were paying attention, you got a whole bunch of freebies today. One thing I'm going to point out is you will have a hard time doing the second part of number 9 on the Google slide. So if you can figure out how to use the shape tool, I know a couple of you have done that because instead of entering an answer, you figured out how to circle the answer. If you can figure out how to use the shape tool, you can draw that out, or you can upload a PDF of this part completed by hand, either on a worksheet that you brought home or on a scrap piece of paper if you're doing all your worksheets electronically. And then you can upload that. The second part of part 9 is going to be good for an extra credit point. And then this is going to be uploading on Thursday. Have a great day, third grade.